Προχωράμε τη ροή του προγράμματός μας με τον κύριο Dr. Νίκο Κυριακούλη, co-founder and managing partner της Core Innovation Group, τον οποίο καλωσορίζουμε με την παρουσίασή του με τίτλο All Driven Factories, Breaking Down Silos for Holistic Maintenance. Καλώς ορίσατε. Εδώ. Παρακαλώ.
Okay. Good morning. For the last 50 years, we have been installing sensors to our factories. Actually, we have filled our factories with many measuring systems, as Tassos showed before, for measuring pressure, quality, specs, KPIs, you name it. Actually, we are collecting mountains of data. The exact figure is not possible to measure, but the estimation is 1 petabyte from a single motor factory. If you are not familiar with petabytes, it's 1,000 terabytes or 1 million gigabytes, whatever helps you to understand better the amount of data. However, although we are still measuring everything, we have not understood that much. And the reason behind it is because we are using only 20% of this data. Only 20% is being used to make decisions, to have insights, and be more sure about what's going on in my factory. The rest, 80%, is considered dark data, leaving literally our factories in the dark. So, this doesn't come without a cost. Every year, for Europe and UK alone, the downtime cost, the unplanned downtime cost, is 92 billion euros. If you do the math, I did it for you, is about 10.5 million every hour. So, we are spending 10.5 million every hour because we are not listening. We are measuring, but we are not really listening what the factory is trying to tell us. So, why is this happening? I think Tassos put it also really nice before. We use a that maintenance log, you name it, and it's there. Then you have something for production. You have some OEE or whatever other scheduling metrics for the production is related, totally different. And the thing is that any alarm, any notification, anything from the one side of maintenance is just noise for production, and just noise to quality, and just noise to any other system that you are being following. So we have what we have achieved to have silos. We have siloed systems, siloed data, and we just use only 20% of this. Predictive maintenance. Predictive maintenance is a really good first step. It's not just good, it's a very good first step, but it's not there what we need. It's an evolution, but not the revolution we need. Why? Because it doesn't tell the full story. It just takes into account machine health-related issues, mostly, like condition monitoring, the lubrication, vibration, temperature, whatever is the system that we have to check the defect, and it's just there. So we need to do more. But don't get me wrong, it's working. And I can show you a case study of ours in EIDAP, in a wastewater treatment facility, that we have installed our system, our predictive maintenance platform, in biological reactors. So what was happening there is that at some point we've seen a degradation, we notified, and after a few days we sent a full analysis to the crew there to have an idea what is going on, the causality, and everything engineering-related matters, if you like. It's a wastewater treatment facility, so you cannot just stop. It's many health-related issues, and some, a big city like Athens needs to have the wastewater being treated, right? We don't want to be like a manure crisis in London. So at some point, they identified the right window, if you like, to stop, and they managed to save the machine. The repair was done on time, meaning that if they didn't, let me put it like that, they had to substitute the entire reactor. The cost only from the reactor is 50,000 euros, without taking into consideration the idle time, the wages, the operational cost, and of course, the health-related issues that wastewaters will not be treated. So predictive maintenance is great, is working, but we can do more. So what is the next step? How we can do more? We have to break down these silos that I mentioned before. And now we need to change the fundamental question. Stop asking when it will fail. You get an indication, but we have to start asking what is going on with my machine, what is going on in my factory. And right now, the latest trends, there are enabling technologies, agentic AI. I'm pretty sure that you are going to listen to it a lot today. So agentic AI is an artificial intelligence system that helps solve too many issues that it wasn't easy, not impossible, but it wasn't easy before because they solve many interoperability issues. So we have to move from these images of separated, siloed, structured, layered data. This is automation hierarchy levels, if you like, from the shop floor to the ERPs. And we start to think of all the data taken into consideration and actually have an integrated intelligence, taking everything into account and start thinking of not adding an extra dashboard, but instead have all the PLCs data related, all the KPIs, all the maintenance, operation manuals, machine manuals, you name it, and have a single conversation. You can start discussing, literally, deterministically, with your machines. You don't have to have too many dashboards. And of course, the knowledge is not only there. You can get reports, you can have historical reports for your records, you can share it with emails, so you don't have to follow a dashboard every day to see what's going on. So you can have, your own archive, if you like. And then you can move beyond maintenance and ask different questions, like, what is the cycle time of my line number 4 for the last 100, 1,000 units, you name it. Or you can ask which stations were in downtime last night or that previous, or make even more different questions and more difficult questions, if you like. So how it is made possible? I will try to make it as simple as I can about this agentic system. So everything starts with this non-universality of different systems and assets out there. So they have like different plugs. What we have done as engineers, not us as core, is that there are protocols like OPC UA, like MQTT, that what they do, it's a universal plug, if you like, that make all the raw data available, right? And then you can have applications that take this data and either display them in a dashboard, or you can have to display the data, sorry, or you can have AI applications or agents or not agents to make meaning out of data. And by make meaning means that you can have contextualized information, so you can have a real-life discussion. So you have the data, you display or not display the data, and then there is a newest protocol about 1 and something year ago. It is called Model Context Protocol, and what it actually does, it goes directly to the data, and it has embedded large language models that you can chat and bring you the meaning out of this data. So in essence, it's like a USB that is universal to all the electric devices nowadays and connects different systems really easy. And of course, you can have an agent. Agent, what it is, an agent, you don't have to program something. You just give an objective, and the system identifies what needs to be done. Not certain tasks, they have an understanding of their own and make decisions on their own. That's why they are called agents. Like you call a travel agent, I want this ticket to there, right? This is how it works. And an extra protocol that is now available to solve the interoperability issues is the agent-to-agent, how these two systems speak with each other. So if you do all this, you can have a single conversation box that you can literally speak with everything you have in your shop floor or even your enterprise. So what we have done in Core is that we have built all these systems, we have built all these protocols. Our solutions are ready for that. So we can take the predictive maintenance data, we can take any OE or any other available system on the shop floor and link it to different agents that we have built, from understanding the manuals of the machines, from an agent that produces reports or make an analysis or have a production. So everything are linked all together. However, industry is still skeptical. From our visits to many factories, many people there just say that, yes, we are mentally there, psychologically not ready, because we are just undergoing a transformation with our newest ERP, or we are going to install a newest SCADA system. Don't get me wrong, they are good. But the idea is that industry still wants to make all the steps. They have to move from automation in Industry 3, have data, have automated system, PLCs, and then move to Industry 4, how to get data and have meaning, cyber-physical systems. But now we are living in Industry 5. Industry 5 is human centricity. You don't have people, to train them. They can just discuss with any system. So the idea is these technologies can actually help you jump to now. You can leapfrog, as they say in English, that you can jump to the present. The future is going to be augmented and autonomous. Augmented, autonomous because it will take decisions on its own. And augmented means that your people in the factories will be empowered to have more time instead of checking different dashboards, to have faster understanding, right? And then can have what makes humans, to have critical thinking and make decisions easier with more concrete and credible results. So latest studies show that these systems, ChatGPTs, DeepSeek, and Gemini of the world, one question leads to several more. They cannot measure it right now, but it's significantly more. But it accelerates understanding. So imagine having something like that in your factory, and you can ask all the different questions that you may have, but not only there. If you imagine that you can ask, but also get actionable answers from these questions. And to me, this is the future of maintenance. And before I leave you, I want to leave you with one thought. If you had just one question, what would you ask your machines? Thank you.